So some more practice with these trinomials. Because there's not a coefficient of 1 here, this is the challenging case. And if you don't have something that you like better, then try this. We're going to multiply the outside terms. 8 times -9 gives me -72. And the trick with this one is to find two numbers that multiply to -72 and add to that middle number 6. So here's all the factors of 72 in red. Since I need to multiply to a -72, one of these has to be positive and one of them has to be negative. The larger one is going to have this sign. So that's going to be positive, making these negative. This adds up to 71, to 34, 21, 14, and finally down here we'll stop. You don't need to go down any further because this is the one we need. These two numbers multiply to -72 and add to 6. So I'm going to split that up. Now you can do this in any of two ways. You could put plus 12a and minus 6a, or minus 6a and plus 12a. It doesn't make any difference either way. You'll get the same thing as far as a factorization. Once you have this as 4 terms, you can factor by grouping. Now you need to factor out the GCF here. What's the greatest common factor here? 4a, which leaves behind 2a plus 3. What can I factor out of this one? Negative 3, which also leaves behind 2a plus 3. If you're not sure about that, check it. If you distribute the -3, you'll get exactly this right here. That's good news. Thanks for the help there, Colby. These match. So that means it's the greatest common factor, and you can factor that out. It'd be 2a plus 3, leaving behind a 4a minus 3. And that's your factorization. If you're worried about, well, wait a minute, wait. What if I put these numbers in a different order? What if you put them in as 8a minus 6a, excuse me, 8a squared minus 6a, and then plus 12a? Is that going to make a difference? Not really. In the end in the end, it's going to work out the same. The GCF here is a 2a, which leaves behind 4a minus 3. Here I can factor out a 3, which leaves behind 4a minus 3. And now 4a minus 3 is my GCF, and it leaves behind 2a plus 3. So you don't have to fret about which way you put it in. Both ways work out fine. Multiplication is commutative, so if you do it this way or this way, you get the same product. So nice. Now I'll show you one more thing about this method that I kind of like, and it's with this example here. So we'll call this one example O. So we'll do 3x squared plus 19x plus 4. All right, so we're back to that case where you don't have a 1 as a leading coefficient. You're going to have to do something special. You can't look for two numbers that multiply to 4 and add to 19. You're not going to find them. Instead, we'll start out by multiplying what? 3 times 4 equals 12. Find two numbers that. Does anyone want to finish off with that? Maybe if you're watching this later, pause the video. Find two numbers that what?
Multiply to 12, add up to 19.
Perfect. Thanks, Arsenio. Multiply to 12 and add to 19. So the 19 is coming from here. The 12 is coming from here. And nothing's jumping in my head right at the go, so I'm just going to make a little table. And let's see what happens. So multiply to 12. That'd be 1 and 12, 2 and 6, and 3 and 4. And add to 19. Well, let's see, this adds to 13, this adds to 8, and that adds to 7. None of these worked. Well, what's that saying then about this polynomial?
It's not
Unfactorable. Prime. It's prime. Now, just a quick FYI on WebAssign, when you do this on WebAssign, instead of typing in the number or the word prime, it's going to ask you to just type in the polynomial again. Type it in unfactored, which I'm not really happy about, but at least if you have a heads up, then hopefully you'll get there. Part of the reason I do like this method is because this is telling you it's prime. That's it. There's nothing else you have to worry about. Like I said earlier, when I did this as a student, we had the guess and check method. We'd say, all right, well, the first has to be a 3x and an x, and then next could be a 1 and a 4 and a 1, or a 2 and a 2, and you have to check all those different possible combinations by multiplying it out. And I always felt uncomfortable when I couldn't find one. I'm like, was I just not clever enough? Or is it really prime? Here, if you get down to this list, and there's no two numbers that satisfy both these conditions, that's it. You can be 100% certain that those are prime. So that's kind of a nice benefit of using this. If you don't like it, if you have something else that you're good at, you're comfortable with, stick with it. All right. But one way or another, you're going to have to get good at factoring these kinds of polynomials. Comments or questions? Doing all right on that one? All right. Let's put this one in the books.